Are you struggling with the development and maintenance of an OT firmware and software inventory? I'm Ralph Langner, and I'll show you in this video how you can get an account of what you have installed easily. If you're like most asset owners, you're using Microsoft Excel for your asset inventory. Funny that I would know that, isn't it? Well, the problem with Excel is that in those spreadsheets you rarely see software or firmware details. You may occasionally see an operating system version. But that certainly is not good enough in today's hyper-connected world, if in the world of the industrial Internet of Things. Now, there are a couple of use cases for which you definitely need detailed software and firmware version information. For example, cybersecurity. How would you be able to determine the vulnerabilities that affect your installed base if you didn't know the operating system versions, the installed patches, the software versions of the applications that you're running, and so on? Another use case would be obsolescence management. Can you tell me right away which of your software products run out of support in the last 6 or 12 months. Just as an example, as you may know, the support for Windows 7 ends at the beginning of 2020. So what you want to be able to do is determine in a couple of minutes where you have those machines installed that you might need to update rather soon. And then there are other very interesting use cases such as engineering and maintenance. So for example, firmware version conflicts, software version conflicts often cause maintenance issues, and in order to identify and resolve those issues, your engineer certainly must be able to identify the versions that they are running. And at the end of the day, what they really want to do is to arrive at standard configurations that can be checked against reality. Now, the reason why we don't see that on a large scale in real life is that so far people have been struggling to automatically collect all this information, which is funny in a way because technically this problem has been solved a long time ago. The solution for this problem is simply that we are using legitimate standard interfaces that allow us to obtain the information from the respective devices. Just as an example, if we are interested in the software that is installed on a given Windows machine, we can use a standardized interface, an official interface by Microsoft. It is called WMI as an acronym for Windows Management Instrumentation. And using WMI, we can just ask the target machine, well, tell me about the operating system version that you're running. Tell me about the license key, for example, for this operating system version, if you're interested in license management. Tell me about all the installed applications and also tell me about the installed patches. And that gives us a wealth of information that we can then process. For network switches and automation gear, it's a little bit different. So how do we get the firmware details? For the network switches, routers, firewalls, etc., there is a standardized interface that is called SNMP, which is an acronym for Simple Network Management Protocol. Again, we can simply use this protocol to ask the switch or the network gear in question, please tell me about your firmware version. And you can imagine what the result is going to be. The switch will politely tell us what it is running. For automation gear, we can use standardized protocols such as Profinet, Ethernet IP, or Modbus. All of these protocols have standardized functions for querying metadata from the device, such as the installed firmware versions. And finally, we might run into some proprietary interfaces. For example, this is the case in respect to Siemens, when we want to query the firmware version that's running on a given PLC, or even in one of the interface I/O modules on the backplane, or in an RTU, we can use proprietary protocols. Now you may wonder what this looks like in real life. What you see here is the OT-based asset discovery software, which is part of our OT-based asset management platform. By the way, you can download an evaluation version of Asset Discovery from langner.com. Just go to the downloads area. Once that we are running OT-based Asset Discovery and have probed the networks that are attached to our Asset Discovery engine, we see details to all the systems that are reachable in these networks. So as an example, we see here that there is a Cisco switch, we see a PLC, we see an engineering station, and in the right pane we get some details. Now for our video we are interested in the software that's installed on those endpoints. So as an example for our engineering station, we see here a breakdown of all the installed software, a whole bunch of security patches, which is what you would expect to see, best case. And then we have a couple of applications. And again, what you see is all the version details for those application packages and libraries. Let's look at the Cisco switch. Then I see the operating system version and the firmware. Or for the Siemens PLC, I do see the firmware version of my CPU, but it even gets better. If I go to modules, I can even see any firmware versions that is running on I/O modules on the backplane. So for example, in this case, on the communications processor CP443-1, firmware version 2.5.5 is running. Let's look at some additional examples. We can switch networks by using this drop-down box here. So here we are looking at a Siemens ET200 RTU, which is accessed via Profinet. And again, you can see all the different modules, the I/O modules in the RTU. And in this one case, for this intelligent I/O module, we see the version information. And if we click on software, again, we see the firmware of the head module of the controller. Final example, in this network, we also have a Rockwell Control Logics running firmware version 16.20. Let's just quickly check the hardware. There it is. And also, again, the modules that are installed for all the I/O modules on the backplane. We also see the firmware version. All of this doesn't require magic. However, it does require a bit of configuration effort though. And in order to make that happen, we go to the network settings for Asset Discovery. And as you can see here, for any single network that Asset Discovery can probe, you can fine-tune the parameters. So, for example, here is the section for WMI, for the Windows Management Instrumentation. Once that you tell Asset Discovery that you want this to be enabled, then it will use WMI in that network setting, in that network segment. However, it will only start to send all the probing packets once that it has discovered that it can reach the service after all. So if that first connection attempt fails, then it will no longer send any further packets using WMI. You can specify credentials for the WMI access either on a network level, on a global level, or even on a device level. SSH will be used for discovering all the software that is installed on Linux or Unix machines. Profinet is the standardized industrial protocol, which gives us the version information on the firmware of automation equipment and also of the I/O interface modules that are installed on the backplane or remotely in the RTU. Then S7 is the proprietary protocol, this is Modbus, and finally Ethernet IP. So as you can see, all you have to do is enable or disable those protocols for a given subnet. And for some protocols such as SNMP and WMI, you might have to specify additional parameters such as the access credentials. Again, this can be done on a network level or on a global level or on a per device level. So how does this look like in OT-based Asset Center where all the data is consolidated? In the device inventory, what we can do is select a given device that we are interested in and then click on Profile to get all the details. And sure enough, the software, or in this case the firmware, along with the version number, is listed in this particular section. Let's do the same thing for a Windows PC. Let's just pick this as an example, click on Profile. And then the list is a bit longer because of all the many software applications and especially patches that are installed on this machine. What you also see here is we can directly go to any known vulnerabilities that affect this device with all its installed software, and even dive down into vulnerabilities that we are interested in, such as this one. And we can always get more information about a given item by just clicking on that link. And that's going to tell us the full story along with where devices are that are affected by this vulnerability. Let's do a final check for a PLC. So let's just pick this one right here. And we can see the firmware version in this section. And for any modules that are I/O modules on the backplane that are installed, I can see the firmware version in this section right here, where all the modules are listed along with the slot that they're in. A different view on the inventory can be obtained by clicking on Software. And this brings me to the listing of software products that I have installed. And they are sorted by the number of installations. I can certainly rearrange the sorting by vendor or name or any other category. So let's just look at this entry right here, Windows 7 Professional. Let's do a profile. And what I would like to point out here is that you can also get obsolescence data this way. So you can see the end of the support for this product, which in this case is January 2020. And then for Windows 7, you can get a listing of all the vulnerabilities. Quite a bunch. And you can see where it is installed. From there, again, you can dive down by just clicking on a given entry. The last thing I want to show you is how this ties into workflow automation. So let's change the area in OT-based Asset Center by going to Workflow. And one thing that we can do is we can define standard configurations, which we also call baselines. So this allows us to define all the software or also the security patches that we want to see on a given standard type of device, such as an HMI station. As an example, let's have a look at this baseline, which defines a standard operator station, and we can check the details by opening the profile. So what we see here is the definition of that baseline, which is a particular hardware product, then required software, which in our case is a specific operating system version, backup software, a whitelisting software, and a security patch. In real life, this would certainly be more than one security patch. And also the baseline has defined prohibited software. Now in the next section, what we see is that OT-based automatically tells you which devices that are associated with that baseline are compliant or non-compliant. So the first two are compliant and the next four are not. If we now want to see details, we just need to click on a given device ID. And if we scroll down to the compliance section, we can see why this particular device is non-compliant, because this required software is missing, first the backup software and then this given security patch. Another workflow that I want to touch on briefly is the vulnerability management. Once that you select CVE for common vulnerability enumeration, you will get a listing of all the known vulnerabilities that affect your installed base, and this is sorted by default by the number of affected devices. Now, if I open any given vulnerability that I'm interested in, then I just need to do a profile. And for this vulnerability, it shows me not just the details of the vulnerability with some additional links, but it also shows me the affected devices that I can now inspect easily. So that wasn't so difficult after all, was it? The best part is you can even check this out in your own environment using the OT-based asset discovery evaluation version that you can download at langner.com. So please check it out and also leave a comment in the section below. Tell us what you like about this approach, what you might be missing, and I'll try to answer any of your comments or questions.